Learning how to set up CI/CD for a Lambda function using GitHub and GitHub Actions is the topic of today's video. Are you interested? So let's get into it. Hello everyone, this is Marco speaking. Today we're going to explore the topic of continuous integration / continuous delivery, aka CI/CD again. But now we're going to see how to do it for Lambda functions on AWS. Okay, great. So how this project is going to work. So let's imagine that you watching the video. Let's imagine that you write the code on your computer using your favorite IDE. PyCharm, VS Code, Vim, whatever, it's up to you. So let's suppose that you write the code on your favorite IDE. Once you finish the changes, you push the code to GitHub. Once the code arrives on GitHub, there's gonna be a GitHub action which will listen the changes on the code and will be triggered. So this GitHub action will be responsible to read the code, zip the code, and send the code to our Lambda project on AWS. So let's get into it. Okay, great. So here we are in the AWS Lambda console. So let's create the Lambda function for our project. So I'm gonna click here. I'm gonna call it test CI/CD function. The name is up to you. In my case, I'm gonna use Python 3.11. The architecture can be x86. And let's click to create the function. Okay, perfect. After a few seconds, this is the Lambda function created by AWS. So what we're going to do now, we're going to copy and paste this code base to a local project in our machine. So let's do this. Okay, great. So here we are with the terminal open on my machine. So what I'm going to do here, I'm going to create a folder for the project. So I'm gonna call it CI/CD Lambda project. It's up to you. So I'm gonna enter in the folder. I'm gonna create a new folder called source code. Okay, so here on this directory that we just created, I'm gonna open up the directory using Finder. And this is the directory with the source code folder. So what I'm gonna do here, I'm gonna open up this directory using PyCharm. So I'm gonna open up PyCharm and open up the project. So I'm gonna click here to open and search for it. Okay, perfect. Now we have the project opened with PyCharm. So I'm gonna create here a new Python file, which is gonna be called the same name as we defined here on Lambda, which is lambda function.py. So it's gonna be here Lambda function. Perfect. So now I'm gonna copy the code base and paste it here. Perfect. So basically we just copied and pasted the code from Lambda function into our local repository. Perfect. So the next thing that we need to do after doing this is to create a new GitHub project. So I'm going to create a new GitHub project, which is going to be integrated with this code base. So whenever we change something here, it's going to send to GitHub, and GitHub will trigger a GitHub action. And the GitHub action will be responsible to update the Lambda project on AWS. So let's do this. Okay, great. So here we are in the GitHub dashboard. So let's create a new project. I'm gonna call it test CI/CD Lambda. It's up to you. In my case, it's gonna be a public repository, but if you prefer, you can use a private one. Let's click to create the repository. Perfect. Now let's follow some steps to send the code base to GitHub. So we're gonna follow some of these commands. First of all, we're going to run this one to create a simple README file. Perfect. Now we have this simple README file. Next, let's initialize Git in our project. So I'm gonna paste this here. Before we proceed, I'm gonna create a new file here called .gitignore. Gitignore. Why do we need this? If you try to see all the files that exist in the repository, you will see that besides the source code, which contains the Lambda function file, we also have this README that we just created. We have this .idea, which is created by PyCharm. And then we have the .git, which manages the Git project itself. And we have this .ds store, which is created by macOS. So I don't want to send the .ds store and the .idea to GitHub. So I'm going to add these two files inside the gitignore. So whenever we send the files to Git, whenever we push the changes to GitHub, it's not going to send the .ds store and the .idea to GitHub, only the other files. So Git will ignore this file and the .idea, which is a folder, to GitHub. Perfect. Now let's add everything to be sent to Git. Let's use the git commit. So we executed the git add dot to send everything to GitHub instead of just the README file. This command here, git add README, it's only adding the README file. But when we send the git add dot, we're actually sending everything to Git. Now let's run the command to commit our changes to Git. If you want to see the changes, we can also see it here. So in our case, we're going to send the Lambda function and the README. We're not going to send the .ds store and the .idea to GitHub because they are actually sent here in this .gitignore file. So let's commit this. Perfect. Now let's define the main branch to be called main. So this command is actually defining the main branch to be called main. Now let's define our remote. And lastly, let's push the changes to GitHub. So let's copy the last command here and paste it here on PyCharm. Perfect. Let's go back to GitHub and refresh the page. As you can see, here we have the README file, the .gitignore, and the source code with our Lambda function code base. Perfect. Now let's define some things to keep going. Let's define the code for our GitHub actions, which will be triggered whenever we push changes to the main branch. Okay, perfect. So what we're going to do next, here on the project, on the root directory, we need to create a new directory called .github. And inside this .github folder, we also need to create a new folder or directory called workflows. Perfect. So here we're going to define our GitHub actions. So the first action that we're going to create is the deploy lambda function .yaml. Perfect. So it's going to be a YAML file, and this is going to be the content. So what we have here, the first thing that we define is the name for the GitHub action. So we're calling it deploy lambda function. Here we're saying that we want to trigger this action whenever we push changes on the source, on the src directory in the project, in the main branch. So whenever we push changes to this path in the project on this branch, we're going to run these jobs. So what we are defining here in the job itself, First, we say that the job will run on a Ubuntu machine, and these are the steps. The first step is to run the checkout action. The checkout action is responsible to give the GitHub action machine access to the code base. After this, we install the zip library in the GitHub Actions machine, so we can run the zip command from Linux, which is this instruction here. After doing this, what we need to do, we actually run the zip command. So here we are accessing the src folder, the src directory, and running the zip command to zip everything here into a file called code.zip. After doing this, we install the AWS CLI on the Ubuntu machine, on the GitHub Actions machine, and then we run this AWS CLI command. We're running the AWS CLI Lambda update function code, and then we pass here the ARN for the Lambda function, and then we pass the binary file, the zip file, to be sent to the Lambda function. So basically here we're passing the zip file to the Lambda function to update our code base. For doing this, we need some environment variables. We need an access key ID, and then we'll also need a secret access key ID. If we try to run this without these variables, it's gonna fail. So let's update our project on GitHub to have these secrets to run this instruction properly. Okay, great. Back to the GitHub project, let's go to settings. And here, let's go to secrets and variables, and then on actions. So now let's define some repository secrets. I'm gonna click here, and let's define our secrets. If we go back to the code base, we should see that the first secret is the AWS access key ID. Let's go here and paste it here. So now I'm gonna paste the access key ID as secret. And let's do the same for the secret access key ID. Let's go here, let's copy the name, paste it here. Now let's paste the value. Perfect. Now we have the AWS access key ID and the secret access key ID. Now we're good to go for our GitHub action. Okay, great. Now let's go back to the code base. Actually, let's make some change here to identify that the code actually changed. So I'm gonna call it updated v2. Perfect. Now let's push the changes and see what's gonna happen on GitHub and the AWS function. So I'm going to run the git add and then git commit. I'm gonna say that feat add GitHub action, and then we're gonna pass an emoji here, instruction worker. Perfect. Now let's push the changes to GitHub. Perfect. Let's go back to the project and see what's going to happen. Let's go to actions, and our action is running here. Let's wait a few minutes to see what's going to happen. Okay, great. After a few minutes, our GitHub action succeeded. Let's go back to the AWS console and see what happened here. So when we go here, then we go to code. As we can see here, the message changed to hello from lambda-updated v2, which is the message that we defined here on our code. Actually, this is quite powerful. We can even do extra files here that the Lambda function will recognize. So for example, if I create a new Python file here like extra utils, and then I define a function here like get lambda message. It's just a simple function to demonstrate that we can even, oh sorry, actually it should be here inside the source code. So actually I can, like, I'm gonna return a simple string here, like a string from another module to demonstrate that we can even create extra files here and extra modules that our integration is still going to work. So from src.nextReutils get lambda message. So if I pass the message here, string from another module, and now let's push the changes and see what's going to happen on GitHub and the AWS function. So git add.git commit feed create second module, and then I'm gonna pass sparkles as an emoji, and then I push the changes. Let's go back to GitHub and see the new action. Okay, perfect. This action also succeeded. So let's go back to the AWS console and see what actually happened here. Let's refresh the page. As you can see, now we have this extra utils, and then we have this from src extra utils get lambda message, just like we defined in the code base, string from another module. And that's it. If you want to create a testing event here on Lambda to see if the function works, so I'm gonna call it test event 1, and then let's save it and let's run the event. Actually, the code failed because of the import statement. Okay, so we could fix it directly on the Lambda console, but let's do it this way. From extra utils get lambda message. So if I try here, like if name equals main, and then I run the lambda handler passing like empty objects here, let's call the lambda function. Actually, let's print it. Okay, perfect. Let's push this and see what's going to happen with our lambda function. Git add, git commit, -m, fix import statement. And this is a bug, so I'm gonna pass here a bug emoji, and then let's push the changes. Let's go back to the GitHub actions, see our action, and wait it to finish. Okay, perfect. After a few seconds, our GitHub action is complete. Let's go back to the AWS console, refresh the page, and the import statement is changed, and also the change that we and the if name equals main that we added in the local version of the code base. So let's run the event again to see if it works. As you can see, here we have the status code 200 and the message, which is the string from another module. As you can see, everything worked successfully in our project. Okay, great. As a bonus section, I'm gonna show to you how you can use GitHub Actions to create automated tests. So what we are going to do, so we're going to create a new branch on GitHub. And then we're gonna make our changes on this new branch, and then we make a pull request to merge into the main branch. So we're gonna create a second GitHub action, which is going to run a set of automated tests on our code base. And we're only going to allow the merge if all test passes on GitHub. So let's work on it. Okay, great. So this is what we created so far. Now let's set up a new branch to start working on our tests and the GitHub actions for running our tests. So right now, if we try to see the branch, we are running on the main branch on GitHub. So what we're going to do, we're going to create a new branch. I'm gonna call it feed new stuff. It's up to you. So this is our new branch that we started working on. What we're going to do next, for running tests for our Python project, I'm going to install a library called pytest. So I'm going to do pip install pytest. In my case, it's already installed because I was making some tests here with this project. Perfect. So on our directory, we're going to use the src for the actual code base, and then we're going to create a new directory, Python directory, for the tests. So I'm going to create here a package called test, and I'm going to create a new test file here. I'm going to call it test Lambda function. And here, what we're going to do, I'm going to define a function called test Lambda function. For now, I'm just going to pass. So let's import from src.lambda function, import get, sorry, actually it should be the Lambda handler. I'm also going to import from src.extrautils get Lambda message. So I'm just going to assert here whether the result for the Lambda handler is an object. Assert if, let's import here the JSON library, import JSON. If this is equals to the Lambda handler passing some empty objects. So this is basically what we're doing. We're defining, we are checking whether this object is equals to what the Lambda handler returns. So let's test it out. So as you can see, the code is failing because of the structure directory that was defined for the code base, because the code could not find some packages properly. So as you can see here, no module named extrautils. For running this properly, I have to make some changes on how we manage our code base and how the code is managed on the Lambda function on AWS. So let's solve the issue first on the local machine, then I'm gonna solve it on the AWS deployed version. So for solving the issues here, basically I need to add the src back here into the import statement. So now when we do this and run the function, let's see. Now the tests are passing correctly. And if we try to see here, so I'm gonna run the pytest on the test directory. Let's see what's gonna happen. So the test passes here as well, as you can see. But the problem is, if I try to deploy the code as it is on AWS, it's gonna fail because here, this function here is only zipping the code inside the code.zip version. So if you don't want to test your code base, if you just want to deploy everything inside the src to the Lambda function, you don't need to make those changes that we're going to do now. But if you want to keep a set of tests for your project separated from the actual code, then you have to do something similar to what I'm going to do now. So instead of going to the src folder here, I'm actually going to zip the entire thing. Zip -r code.zip, and then we're gonna zip actually the whole project. And that's it. So let's go back to the tests. So first of all, let's update this branches here to push the changes when we run the code on this new branch. So right now we are running the code on this feed new stuff. So we want to trigger the GitHub action for this branch as well for testing. So let's copy this, paste it here. Actually, I'm going to remove this because now I want to run this for everything on the code base. So whenever we push into the main branch and the feed new stuff branch is going to trigger this GitHub action. This is the first action to deploy the code. After this, we're gonna create a second GitHub action for running the tests whenever we make a pull request to the code base. That's it. Okay, so let's push the changes to GitHub to see what we did in action. But before we proceed, I'm going to add here all the PyCache files. Okay, great. Now we have all the PyCache files into the git ignore. So let's add everything. Git add, git commit, test, add tests to the code base. I'm gonna add some emojis here, white check mark and heavy check mark. And then we push our changes to this new branch. Since it's a new branch, then we need to pass the setup string to define the branch on the remote. Perfect. Now let's go back to GitHub to see what we did in action. Okay, great. So the GitHub action failed because I forgot to change the path to read the new file. Since we changed here to the path for zipping the entire project, now it's not just the src anymore. So let's fix this and push the changes again. Git add, git commit, fix, update, GitHub action script. Then we push. Let's go back here to actions. Okay, great. Now the GitHub action worked. Let's go back to the Lambda function. Okay, great. As you can see, now we have the src and the test. So we actually have the entire code base here. So to make the code work on these conditions, we actually need to change here on the runtime settings the path for the Lambda handler. Now it's going to be the src.lambda function.lambda handler. And then we save. Perfect. Now let's try it out again. So if I go to test, I already have a test here. As you can see, everything worked as we expected. So the code is working even when we have this new structure to put everything inside the src. Perfect. Now we have a test, and then we have the code also running on the Lambda function with the new structure using the src module. If we run here, you can see that the tests are passing. Test passed. Now, let's define the second GitHub action to be triggered whenever we make a pull request to the main branch. So before we actually create the GitHub action script, let's do something. I'm going to create a requirements file, requirements.txt. This is going to be helpful for the code to run on the GitHub action machine. So the GitHub action can know what packages it needs to install to run the code properly. So by having this requirements.txt file, the code can run properly on the GitHub machine for the test. This is the requirements file. Now let's go here to workflows. Let's define a new GitHub action script. I'm gonna call it check lambda function.yaml. Let's add this. So this is the script. So whenever we make a pull request, we're going to run this job. So we are running the checkout command to have access to the code base. Then we set up Python on the GitHub Actions machine. Then we install the dependencies. So here we can see that we need the requirements file here in this case. And then we actually run the PyTest library inside the test directory on the code base. So, and that's it. Now we have our second GitHub action to test the code. So whenever we make a pull request, this script will run. So let's push this, git add, git commit. We're gonna call it feed a new script for running tests. and then we define a construction worker emoji. Then we push the code. Perfect. So let's go back to the GitHub project. When we go here, it actually executed a script, but this is not the new script that we defined right now. This is the old script that we defined to run whenever we push our code base to the new stuff branch and the main branch. So let's remove this to only run it on the main branch. I'm going to update this, git commit, fix, update initial GitHub action script. And then we push the changes. Now when we go back to GitHub, we should not see any script running, because we updated the first script to only deploy the code base whenever we push changes to the main branch. The second script to test the code base is only going to run when we make a pull request on our code. So for testing this, let's go back to the project and let's create a pull request. So let's go here on the test new stuff and let's contribute making a pull request to the main branch. So I'm gonna do like a summary here. New stuff to the code. Okay, so this is here we can see what we defined. We defined the new check lambda function.yaml. We defined some changes on the deploy lambda function. And we created our tests. So let's create the pull request. And as you can see, the tests started to run because we defined it to run whenever we make pull requests. So let's see it here, running on GitHub. It's actually run the test right now, and it failed. Why it failed? Because of the path directory. Okay, so let's fix this and run it again. Okay, great. It took me some minutes to find out what was happening in my case. It turns out that my code was failing because there was a conflict with this branch and the destination branch, which is the main branch. There was a conflict in the code. Because of this conflict, the GitHub actions was actually using an outdated version of the code. Once I found this issue and fixed it and solved the conflicts, now everything started to work. As you can see here, the final version of the GitHub action is actually running. If you go here, we can see that the GitHub actions machine actually executed our test, which is the test lambda function.py, which is the test that we defined here. I also decided to update the setup Python version because it turns out that there's a newer version of this script. So this is my final script to run the tests, to run the Python tests on a GitHub Actions machine. And that's pretty much it. Now if you go here to the pull request, and then we can merge the code to the main branch. And that's it. Now when we go back to the project, it is going to run the script to deploy it on the Lambda function, just as we defined the main script. As you can see here, this script is finished running. So when we go back to the Lambda function, the code is updated here. Let's close this. As you can see here, we go here to the test. As you can see, this is the test that we defined. If we run the test, you can see that the function is actually working on the Lambda project. And that's it. Now you know how to set up CI/CD using GitHub Actions for Lambda functions on AWS. I hope you liked it, and I see you in the next time.